Welcome to Retrofitting Our Reality, a podcast brought to you by Artus. Artus is a climate tech company changing the way we cool and heat our buildings. I'm Rebecca Stewart, CEO and co-founder of Artus, and it's people like my guest today who give me the unwavering belief that we can do better for our people, planet, and with less materials. Faraby joins us here in Hilson Moran's award-winning office space, Living Lab, a home for innovation, collaboration, and a test bed for innovation in our industry. We actually recommend that you watch this podcast as we'll be sketching throughout. Faraby, very good to have you in the studio. Faraby's taken his time out from a very busy schedule of making our spaces better and our nation's spaces better. So thank you very much for doing that, Faraby. Please introduce yourself.
Thank you for having me, Rebecca. So I'm Faraby Farid, so I'm the technical lead for real estate developments and energy strategy at the Crown Estate. My background is in mechanical engineering, so I've been designing buildings for about 2 decades now. I started my career at Arup designing the Qatar National Museum, so a very iconic building in the middle of a desert. So that's where my sustainability mindset came in. How do we make something sustainable in a place where it can't be? Then I moved on, did lots of other projects, and my most recent one before I joined the Crown Estate was 8 Bishopsgate. So I did that from the beginning to the end, and it was the first BREEAM Outstanding tall building in the UK.
I mean, Faraby, that's amazing. And what has that done? What has that experience done to give you your working passion and in the work that you do today and the purpose in the work that you do today?
Well, it's every single project has given me kind of the belief that we can do better. So thinking outside of the box and doing something differently does yield better results. And what I found, the reason I kind of made the move to the Crown Estate was I started doing my second 50-story building, and I was having the same conversations I was having 10 years ago on 8 Bishopsgate. Yeah. So I thought, okay, so instead of doing one project at a time, how can I influence a whole part of a city? So then the opportunity came up to kind of make an influence in the Crown Estate, made the move. And yeah, it's all about sustainability and keeping our assets alive for as long as possible and creating the best quality of spaces.
And bringing in Roger Olsen, who also joins us here today to kind of co-sketch with Faraby and Ideate. Roger, you are always a believer of out-the-box thinking and doing something differently. So thank you for coming and joining us today.
I'll just introduce myself. So I'm Roger Olsen. I worked as a consulting engineer for many years. And after a long time, I thought there might be a better system out there. And so I invented what became Artus. And I'm so pleased that it's growing in use, and it's helping you, Faraby, decarbonise the buildings, because we're all so passionate about doing this stuff, aren't we?
The reason why I've asked you both to come along today is because I love the way that you work together and build on ideas together. So we are going to do a sketch session today, doing exactly that. Faraby, you have brought us a problem. So we're going to start with this problem, and within 30 minutes we're going to have solved it.
How hard can it be?
So Faraby, do introduce to us the problem that you have.
So our problem is, if you walk around central London, typical West End, you'll see beautiful old buildings like this. These have been standing for hundreds of years, and they need to stand for hundreds of years coming forward. But inside, they're not great spaces. They weren't designed for the uses that we have now. The fabric isn't built for purpose. It leaks out heat throughout the year. They were designed for different uses, such as cinemas, theatres. Some of them were even factories. And we have these type of buildings all over central London in all of the great estates. So we want to make this sustainable, fit for purpose for the next 100 years. And how do we do that is the problem.
Fantastic. And we all know and recognise these buildings, don't we? And we love them, and they give us that sense of belonging to London and the global city that London is. So that's a great problem to have. What does good look like? What are we trying to get to within 30 minutes?
Making it a great quality space internally, and generating the maximum amount of revenue we can from them.
Yep.
So that they'll be fit for purpose for another 100 years.
Okay, so making it viable.
And stopping them being, energy, well, not gas guzzlers, because that's a bit, detrimental, but they use more energy than they could otherwise do.
Yeah, exactly.
And we're all trying to save energy and carbon.
Yeah.
I mean, that's a great challenge, very, very hard thing to actually play out, especially the viability side of it, I imagine, in terms of the rent rates and the upfront capital cost of refurbishment. Roger, tell us how we're going to start tackling this problem.
Right, so can I start drawing now?
Yes.
Yes, so what you need to know about this building is, so this is the environment, first of all. It's got a lot of traffic around it. So I'm going to badly draw, and in the wrong colour, a London bus, something like that. So it's got traffic, and it's got... if I was braver, I'd draw a happy bus driver in front of it, but I'm not really good enough
We've
like
got
that.
square wheels.
Yes, so that's a very badly drawn London bus, and the whole environment is noisy, and there's traffic fumes and stuff like that. And when this was first built, it would have been naturally ventilated. It would be, horses. There are other smells, I think, to do with horses, I guess. But it would be a very different, it wouldn't be as noisy and polluted as it is at the moment. So that's a challenge to the original method of dealing with the building, the natural ventilation. So we have to look at other ideas. So first of all, it's the environment, it's the traffic and the noise around the outside. The next thing is the standard way of looking at these challenges is fabric first. So you start off with looking at your fabric. This is stone from at least 100 years ago, no insulation at all, and the single glazed windows. So we have to look at what we can deal with that, passive insulation, that sort of stuff. So I suppose we can start drawing walls now, can't we, Faraby?
Yeah.
So if that is your piece of wall, something like that, you've got a window in there, and you've got a bit more wall, and then you've got a floor in there. So this is absolutely classic. We've all been in buildings like this. And what you can do with that window, that's single glazed. So there's a very nifty solution to make it better, which you're going to explain now.
So the easiest way of dealing with this problem currently is you put a secondary glazing system in. What that does, though, is lose all of this area and create lots of problems of condensation between that new glazing line and the original single glaze line. So this is not something we should be carrying on doing. So we should look into the innovations in the market and what else is possible.
So you're saying here that this is what traditionally has been the way of upgrading, is to do a second glazing.
Yeah.
But actually there are better methods.
There are better methods.
Good, because that looks quite intrusive as to the architecture.
You lose up to 400 mil of net lettable space all around the perimeter facades.
But you've got a cunning plan.
I've got a cunning plan. It is expensive. That's why it hasn't had a good uptake. But if you use vacuum-insulated glass, which is the same thickness as a single glazed panel that's usually in these heritage buildings, you can get a double glazed performance out of the same thickness.
Okay.
Like I said, they are expensive, so that's why the uptake has been bad. But actually, before you get to that vacuum-insulated glass panel, you do need to solve the issue of the leakiness around the frame.
So this is air leakiness. This is not water. This is air, going through the facade.
Can I just ask whether, because you said it's expensive, but you've also said it helps with the net lettable space inside. So there must be a trade-off. You must go, well, actually, we pay a bit more here. The returns that we're going to get.
So traditional cost consulting don't look at it that way. So this is where you need to be pushing it from the client side to actually explore these options and weigh it up in that way. So it's, for us, we hold our assets for the long term. So actually, we don't look at just the development side. We look at development and operation.
Okay.
So we need to equate it to the energy saving over the lifetime and the net revenue generated for doing a different...
Is this quite unique? Are there many other developers that hold assets for that long, or it gives you a good
I think it's
position?
quite unique for us because we hold our assets probably forever.
Yeah.
So
and they have you. Do all developers have a technical team that is able to
Not like Faraby.
to pull their project teams through, so you can balance CapEx with return on investment?
I think the market is changing, so developers are having more technical insight in-house.
Yeah.
But generally, they usually don't have a full engineering team looking at all their assets.
Yeah.
So this is what we try to change at the Crown Estate.
Well, actually, by you guys demonstrating how it can be done, hopefully that, you are in a nice position in that it's, you are in it for a long time.
It prompts the industry, doesn't it? If these guys can do it with a fairly challenging old building, that's great.
But also, presumably the cost of products, of innovative products coming to market goes down if you've got you've got a leader and that's giving you some volume.
People get reassured that it works. It's not insanely expensive. If they did it there, the costs stacked up. Yeah.
So then these vacuum double glazed windows might get cheaper.
Yeah.
You go for it, Faraby.
And that is what we're hoping happens. So if we start rolling it out on our estate, then actually there will be a market for it.
Yeah.
And then others in the other great estates can pick it up as well.
So the other thing we talked about, or that we've generally talked about in the past, is insulation. So this is the classic way of stopping heat leaking out of built windows, and there's a massive UK building insulation project going on. So the best place for insulation, I'll borrow your black pen so it shows up actually. The best place, of course, really for insulation is on the outside. So I'll draw it like that. Like this. So that's the best place because it's the warm wall construction. It keeps this fabric dry, keeps the rain off, the rest of it. But you can imagine what lovely, great insulation panels would look like.
Regent Street looks entirely different.
That wouldn't get very many votes. That wouldn't get very many votes.
Yeah.
So actually, the challenge therefore is to put the insulation on the inside to some extent, as far as you can, but then. Of course, you start to encroach on your net lettable.
So
there's a bit of a trade-off, and it's quite tricky. And I never actually heard what the answer was.
So again, on this one, there's high performance insulation which doesn't take up 300 mil; it takes up 100 mil.
Yes,
it's again more expensive than the usual insulation.
But your return.
But then if you roll it out in mass, then actually it brings down the cost.
Yeah. So you've had good experience of utilising that.
We're trying to, yes, yeah.
Okay.
Because a lot of these buildings don't really have massive floor plates either. So actually, the most amount of net lettable you can gain, obviously, creates us more opportunities to do this kind of innovation.
Yeah.
So one of the things I've been pushing for since I've joined the Crown Estate is actually getting our consultants, our design teams, our QSs to think differently.
Yeah.
So actually, where a QS would have said, actually, that's too expensive, we wouldn't do it.
Yeah.
I would say no. We need to actually have the cost, carbon, and lettable implications on that
on one spreadsheet.
Compare it against the usual, and then we'll make the decision.
Yeah. Does the Crown Estate have an ROI? You're not going to be able to answer this, I don't think.
I can't answer that.
No. This is great. So we've
tell
talked
you.
about.
But everybody wants a cost-effective solution.
Everybody does.
Yeah. So all of our buildings, we do have to have a minimum threshold of return. So that is kind of the baseline of all of our projects. We just can't tell you that, but
it'd be lovely to think that. This is outstanding real estate, isn't it? It's kind of top tier in the country. But it'd be nice to think that the lessons that you're learning and deploying on here can actually go to your very typical kind of 1960s, 70s.
Yeah. So one of our kind of the Crown Estate's goal is prosperity for the nation.
Yeah.
So if we can innovate the market and bring costs down on these kind of innovations, it will help the wider the market.
How do you pass on that learning?
Well, it's doing things like this, sharing what we've learned.
Write it up as a case study.
Write it up.
Put it on LinkedIn.
Yeah, you can. This is the thing.
Yes,
you can
exactly.
do differently.
Yep.
Okay.
And I think that's key. We do need to share our knowledge in the industry because our industry is very change-averse. Contractors don't like doing things differently. Consultants don't like doing things differently because they're scared they're going to get pushback. So it is all about making it known widely so that actually you can feel more comfortable trying to innovate.
But it's that's quite a position you have, Faraby, to actually show in part the way and to be able to try it out, stick your neck out.
Yeah.
If it goes wrong, that's it's a lesson learned. So you try again.
Yeah.
Shall we do the next bit of the
Yeah.
So that's the sort of the close up on the fabric. What we can do or can't do realistically. Then if I draw a very badly drawn cross section through the building.
Yeah.
So if that is street level there, and here's the bus. There, and our building. So I'm going to be drawing over this. Sorry about that. So the building is something like this here. So and there are floors in here.
Yeah.
Okay. So when it was first built, there would be natural ventilation going through the windows, and you keep it cool like that. We can't really do that now at the moment because of the buses and the noise and stuff like that. Now there's a whole theory that in future this might get, if we get electric vehicles everywhere, that will all get quieter with less pollution.
Or we pedestrianise.
Yes, pedestrianise, yes, some of these major roads, yes, which is quite nice. But it's not necessarily the perfect solution. You still get noise, background noise from other things. And then there's the whole thing about comfort and conditioning inside here. So then you often end up with things like a sealed facade. So here's your windows here.
So you can't open the windows.
You can't open the windows.
Or maybe they're locked, but you would choose to not open the windows.
Okay.
I mean, there are mixed mode buildings, as it's called, where you open the windows at the right time of year when it's advantageous. But you've got to rely on people to do that the right way, and then.
So
this person here opens the window, and that person there doesn't like it, or the other way around.
And one of the other things we found while looking at mixed mode is actually, does the additional embodied carbon that's included in building an openable window worth doing over the long term?
Yeah, quite.
So the additional embodied carbon, what's in the lock, the opener?
So you need more material for an openable window. And if it's a full, proper mixed mode system, it will be automated. So you'll have motors and control systems and things like that.
And
do people like that? Or do they feel take back control of?
They don't seem to be widely used, I think, is a fair answer to that.
That is the thing. But actually, control is a really good point to cover. If you give customers the feeling of control, they feel better in a space. So even if they actually don't have the control, if they feel like they can control it, they have less complaints.
So actually, you have an agency team, don't you, within the Crown as well? You have your agents as well. Do they really help you understand what it is about the environment that's going to attract the? We
do get to the bottom of the complaints, probably a bit more in more detail than in other places. But like I said, it is the feeling of control. So there's like AI-based control systems that's out in the market. Actually, Hilton Moran, the space we're in, they've kind of innovated there as well. A system called Attain, which modulates the systems in the building and gives notifications to the customer. So like tomorrow.
So yeah, that's important. That feedback. Okay, so we've got closed. Well,
so an option, to open the windows at the right time, but actually most of the time it's going to be air conditioned, and therefore the next step is to look. So we looked at the fabric. The next step is to look at where you're getting your cooling and your heating from in the most energy efficient manner. And the traditional thing is to have big metal boxes on the roof.
Doing that doesn't really work for us.
Yes, it's not so pretty. Yes,
is it really? I mean, relatively to that elevation, because it is quite big, isn't it? This plant.
Yes, I mean, plant space is probably something like 8% of the floor area served. Yeah. So of that floor area there, it's probably about 8% of that area will be the plant on the roof, something of that order.
So I mean, because we don't want to do any carbon-based plants, so no gas. So the ideal solution is obviously heat pumps. Heat pumps will need to go on the roof, and heat pumps take up pretty much a whole floor height.
Right.
And if we don't put it there, we'll have to put it there, which means we lose a whole floor of lettable area.
Faraby, what are you going to do about this?
Well,
so this
next cunning plan. Right. Well, I'll set you up and you answer it. So you could have these big boxes up here, but actually a better way of doing it is to have some sort of energy source down here under the ground. Actually, I think you're putting it under the streets, aren't you? Probably.
So lots of these heritage buildings do have
basements.
Okay.
Yes.
And they're sometimes not really usable in normal sense of the way because the height's constrained and things like that.
So for people?
So for people, it's not great. And actually, if you touch basements, there's a new regulations you have to meet as well. So like building safety, fire safety.
You're putting people in it.
Exactly.
Okay.
But you can put tanks in there. So you can fill that basement full of water and make that a thermal store. So actually, if you had a thermal store, then that heat pump doesn't need to be designed to be as big. So you don't need to serve the peak load for that 40-degree 5 days of the year. So you can size it for the nominal. So instead of having 2 of these boxes, you've only got the 1 box, and then that modulates by heating and cooling the thermal stores.
And have you seen this trade-off work? Have you seen commercially?
Yeah. And then you can go even further with have phase change materials in the thermal stores.
And what does that do? Reduce the volume required for the thermal store? Okay.
So phase change materials are things which go from ice to water or water to ice. So there's, for a fairly small space, there's a lot of energy coming in or going out. So that's how phase change materials work. So you get a lot of benefit out of a relatively small volume of stuff down there. So water heating or cooling water is one thing, but you say you can have ice balls.
Yeah.
And then you can use it in your gin and tonics for the
so
whatever bar you've got on the ground.
So these ice balls are a bit like those plastic things you put in your freezer you put in your picnic bag later on.
Yeah.
Probably don't want to put it in your drink.
No. Okay. Different kind of ice.
Yeah, but so if we can maximize the plant in the basement, so kind of storage, water source heat pumps, and just minimum amount of plant on the roof, then actually we get rid of that problem. But if the planners were amenable to having extra mass on the roof, we could actually use it for amenity spaces, adding greenery.
Just going to try drawing some palm trees up here. Do you think
palm trees?
Do you think you'll go for palm trees on the roof, or are you going for a?
I'm happy with any type of greenery, to be honest.
And I'm going to do some little sheep as well. I mean, maybe that's going a bit far.
But one of the other things, obviously, if you
Faraby,
can do.
Can I just ask, have you got some, do you have a stat for how much of St James's, for example, has got green rooftop?
Not at the moment, because we've only just started our development pipeline.
Okay.
But every new development we're doing has green roofs.
And the vertical. During construction as well, aren't you using kind of
so during construction
green?
we're putting green hoarding on all of our construction sites. That's
lovely.
Kind of a trademark we're trying to... Vertical Meadows, another innovative company.
Yeah.
And we're using Vertical Meadows kind of meanwhile usage as well. So like they're meadows in bags that can live on vacant sites while we're deciding what to do with them.
Oh, fantastic. And what do you do?
Part of this is, if you look at the map of where you are in central London, you can get a green corridor. So there's huge benefits for nature and bees and birds and things if you can connect up green bits fairly close to each other, because then the bees and the birds can actually literally go from one bit to the other, rather than there's one tiny clump of garden or something on this building and the next bit's miles away. So
it's the
building a green corridor as far as you can with these bits of garden on the roof is absolutely brilliant.
So it's that original Nash vision of connecting the two parks, St James's to Regent Street.
Oh, right.
So we want to achieve that hundreds of years later.
Right.
And one way to do that would be obviously take away as much plant from the roof as possible.
Mechanical plant.
We want
green
plant. We want green plant.
Yes.
To do that, we need kind of a different energy source. So this is where Roger was starting to draw pipes in the ground. So it's district energy. This is where the UK is heading towards. And I'm a big proponent of district energy networks, because if you design it properly, you can start losing all of the mechanical plant on the roof.
So maximising that space for humans and nature
Exactly.
on the roof.
And it's,
okay.
it's an amenity as well. Like, it's just nice to go up on the roof,
yeah,
isn't it?
lovely.
And
Well,
there's
it's such a beautiful space.
Yes, just a bit of greenery around you.
And
It just-
humans need it. You need to come
Exactly.
up and out
Exactly.
there.
Yes.
So again, this is where having a contiguous estate and long-term view helps, because we could sacrifice one or two of these buildings
The inside of them.
well,
Not
for
the
the roof,
facade.
because
Okay.
to do a district energy network, you'll still need the plant somewhere. It just doesn't have to be in every building. So we can sacrifice one or two buildings to benefit 20 other buildings. So one of them, where the roof isn't as contentious or useful, you put a plant there,
Okay.
and then you serve the heating and cooling through those pipes in the ground into these buildings, which actually the roof is very useful.
Wouldn't need anything.
No.
So, Faraby, are you saying...
And it's all much lower energy.
Yeah.
There's potential for making a far more efficient generation of heating and cooling,
Yeah.
and greatly reducing your energy use and therefore your carbon use, your operational carbon.
Why? Because the heating and cooling inside those pipes...
It can be made more efficient.
Yeah.
You know, with all of these things here will greatly reduce the energy consumption rather than having a standard thing on the
how
roof.
is it more efficient?
You will run it at better temperatures, and you'll choose your plant carefully.
Yeah.
If you've got a centralised plant, which have all the benefits of good choice of plant, you wouldn't have to be the compromises on the selections that you have for all of this.
Easiest way to explain it is every single building had plant on the roof, they'll be sized for the maximum requirement of that building.
Yeah, quite.
If you join up 5 buildings together, it will be sized for the nominal load of that 5 building, because all 5 buildings are not going to be operating at that peak load at the same time. So instead of having 5 times that, you might have 3 times.
Okay.
So actually
Kind of the
reducing the
average
quantity of the kit, which reduces the embodied carbon of that
Lovely.
kit. And then because you're operating more dynamically, you've got information coming back from each of the building's control systems. You can run these at variable temperatures, which means actually the whole operation gets much more operational carbon
higher
efficient.
chilled water temperatures and lower hot
Yes.
water temperatures
So
than otherwise you would need
if you
to.
elevate the chilled water temperatures, the cooling water is not so cold, so the chillers don't have to work so hard, and therefore they're more energy efficient and they use less energy. It's all about the kit not working so hard.
Okay, this
And
is
it's
fantastic.
the same thing with the heating. So the heating water is not so hot, it's just warm water rather than really hot water. So the equipment that generates it doesn't have to work so hard, and it's more efficient.
So Faraby, what's been your hurdle? Because I can imagine, you might have a developer in your team who's responsible for this building that you're trying to sacrifice. How does that conversation play out?
It's linking up multiple conversations and multiple project work streams is the biggest hurdle. So this development has a PC deadline of, let's say, next year, whereas we don't know if the district energy network can be up and
PC
running.
is practical completion. That's when it's really got to be finished to all
Right.
intents and purposes, and the folk move in, and that's a really key
So
deadline for a building.
you need to do that this year, but the district energy is going to take 10 years or something.
Potentially. And
Right.
so how do you future-proof it for that and design this so that actually it's designed in a way so you do have to put this in at day one, but then it's designed in a way so you can take that off and make use of that.
Oh,
at day
Faraby, do you
two.
wake up at like 3 o'clock in the morning and go, oh, I've got it. I know how I need to persuade so-and-so in my team.
Faraby's got young children, so
I don't sleep,
Okay.
but yes.
Quite
A lot of
jigsaw pieces.
good solutions come to me in the shower. I don't know if I use that.
Yeah, well, that's what they say, isn't it?
well, Archimedes in the bath, yeah, exactly.
8 Bishopsgate's louvers on the side came to me in the shower.
Really?
Oh,
We
how
don't have to use
wonderful.
any of this.
Yes.
No, I think that's
I
great.
remember having an idea when I was shaving, actually.
Yeah.
Because your mind is
Yes.
somewhere else and it
Yes,
just pops,
exactly.
it's free to
Yes.
then pop up.
You
When
don't have to think about shaving,
One of the other reasons I'm really pushing for a district energy network, I mean, other than the wider benefits, is reduces urban heat island effect.
Yeah.
So again, if you think about every building having those on the roof, throwing up heat, that's actually making this
Even heat
area.
pumps?
Yeah, heat
Yeah.
pumps are always.
So
Throwing up heat
if you look
from
on
the
the internet
rooftops.
at a heat map of London, you'll see the central part of London is
Yeah.
something like 8 degrees
Yeah.
warmer because of exactly that effect.
You
The
could
Faraby's-
get tropical plants, however.
Yeah,
So you can have
and
the
interestingly,
palm trees.
on that same heat map, you can pick out where the parks are because the parks are that much cooler
Yeah.
and the buildings are that much. It's really dramatic.
Have you seen, are there examples of other cities in the world that have effectively used district cooling?
Yep. Our closest example is Paris, and they've got the oldest district cooling network in Europe.
Really?
And actually, majority.
Really?
I didn't know that.
Yeah.
Yeah, wow.
I want to go and see it
Well
actually.
done then.
Yes. Right, you and
And
me.
it's still running.
Yeah.
And
Yeah.
it's still
Let's
running
go.
efficiently and
Yeah.
effectively today. Yeah.
And they're looking into new technologies. Like during the Olympics, they used one of the aqua parks to kind of do a district heating network around it. So that, and majority of Europe, I think 60% of Europe's heating is through district energy networks. We're in the UK the furthest behind.
Okay.
And currently 2% probably of heating is done by district energy.
Okay. Amazing.
but-
Yet we're the most advanced in terms of what we're pushing for 2030.
Yeah.
I think.
So-
So we're coming from a more difficult position potentially with.
Yeah, and in government, it has been recognised that this is one of the routes
Okay.
to decarbonisation of the
Okay.
UK.
There's good conversation about it.
So every planning and every local authority has to look at this type
Oh,
of
that's fantastic.
solution.
Yeah, so it's a real driver to help support you take this up.
Yeah.
Okay. So we've been through this. This building is feeling
outside,
great. I really
yes, the outside,
currently
yes,
would like to be a
yes.
tenant in it. So this is the heating and cooling.
Of the
And the ventilation
and the
of the
source.
building.
Yeah.
Yes. So now we turn our attention to the inside. Do we?
Yeah.
Shall I?
Yeah, go for
Well,
it.
Yes. So I'm going to try and. If that is 1 meter, I'll try and keep.
So while Roger draws,
Yeah.
most of these so every building is different, and every building, so in the West End, has over the years had lots of work done to it. So some of them started off as 3 or 4 different buildings. Some of them started off as one, but a completely different use. So as an example, let's say this used to be a cinema. So some of these floors aren't aligned. So one of the tricky aspects of heritage buildings is figuring out how to make use of the space you have internally to maximize it and make it fit for purpose in the coming years.
And some of them have very high glazing, and the glazing goes right down to floor level. So
Yeah.
it's not at waist height. It's right down there, which is therefore a challenge.
Yeah,
So when you're coming down to air conditioning, you were saying, excuse me, that you can do a raised floor system.
Yeah.
But there's maybe not. So there's a void in here. That's a raised floor. You'd hear these things when you walk over them. They echo a bit. But there's probably not much space because actually, when your letting agents are coming in, they really want a clear height in there. I'm going to run off the edge of the paper here, aren't I? A
2.8 is what we aspire for.
Okay.
Oh, right, I'm going to
but-
cross that out then.
Well, 2.7 to 2.9 is
Right, okay.
is good,
2.7 to 2.9,
but
So that's from the
which
finished
is
floor height.
9 feet in the old money.
yeah. So from the
Because
floor height,
these bear in mind, these buildings were all built
Yeah.
in feet and inches.
yeah,
So yes, you want about 2.7 to 2.9 metres clear if you
Yeah.
possibly can.
Yeah.
to the lowest point of wherever the lighting and the services
Where
on
the
the roof
Okay.
would be,
Yes.
on the ceiling would be. But the problem is, some of these buildings, from there to the slab, is less than that. We
Right.
don't even get 2.7.
And you can't kind of pull them up.
No.
Well, you can, but there's lots of embodied carbon impact
Right.
and heritage impact,
Right.
obviously, getting that up
And cost.
and cost.
So this thing here this is a concrete floor probably. So yes, as
So
you
yeah,
say,
so a lot of our buildings, we can't even achieve 2.7 kind of slab to the underside of beams. So what do we do there? So the usual ways of thinking is obviously, again, we'll start with the cheap and cheerful way of doing it is VRF systems. You either
so this is variable refrigerant volume system.
Yeah.
So this is the systems with refrigerant in the pipework, fairly small copper pipes,
Yeah.
but lots of refrigerant being needed for it.
Which is high carbon, has lots of leakage, and doesn't give good quality of space. It's not very easy to control, but it's cheap and it's very quick to install.
Yeah.
So that with secondary glazing, the RF system has kind of been the norm to kind of update these type of buildings.
So if you needed, if you've got a tenant going out and a new one coming in as quickly as possible, presumably.
Yeah.
So refrigerant-based systems are going to give you the ability to
Turn them around the quickest.
in like how long?
6 months,
6 months.
as opposed to redoing
All
all
of
the
this.
control, all the central systems to water-based and
Which would then take twice as long,
Yeah.
if not more.
Yeah.
Okay. And it's
and a
going to be
different type
cheaper.
of contractor as well involved in those type of.
Right. Okay.
But I'm not a big fan of refrigerant systems because, like I said, it's got whole life carbon wise, it's not great because there's lots of leakage from the refrigerant.
Okay.
So you have to keep refilling it every 6 years, or every couple of years.
Okay.
And they don't create great quality of space.
It's got a high global warming potential, although they're
Exactly.
getting better.
They are getting better, but the cheap and cheerful ones are still using old refrigerant, which is high GWP.
Okay. So
global warming.
there's a challenge, a water-based system that you can retrofit in 6 months.
Yep. So the next option that everyone knows about is Famke units. But what you have there is you'll have big boxes which need ductwork to kind of serve around the space.
And get over the downstanding beams that you've inherited.
So then that
Or under.
doesn't really work for us anymore. So if we started off with less than 2.7, after you put ductwork in, it gets down to 2.5, 2.4. If you get to those levels, this is not going to be.
I have to say we
Yes.
have a solution for that at
Yes.
this point.
I mean, just to go back, wind back slightly, just say on that diagram, this is a concrete floor
Yeah.
probably, and these are downstand beams. The beams are necessary to hold the floor up and
Yeah.
stop vibration and stuff. So you can't avoid having these down. You can't just
Yeah.
cut them out or something. It's essential. Well, A, they're old and
Yeah, I
been
mean,
holding
it-
building up for 100 years. And B, you couldn't remove them and have anything
No,
practical that was a substitute. Even
No.
steel beams
Yeah.
would be something similar. So you're pretty well stuck with something projecting down into that space.
And,
so that, as you
because
say, it's
they're
about
so
how
old,
to-
you don't want to penetrate through them
No.
either.
Yes.
Um,
You can't ring up the original structural engineer and say, give us your calcs, because
Yeah.
they... 'cause
Sadly
they-
underground.
Yeah.
Yes.
So if
the
there
water
was a solution that didn't have ducts and kind of had the same form factor as cassette units on VRF, that is kind of what we would propose. And it sits between those beams and then maximizes that floor to ceiling height in the space.
And have you seen? So again, have you seen this work? Have you managed to convince away from the refrigerant to the water system in a tight tenant turnaround building?
Because I've kind of set the technical standards for our developments, I have said there will be no gas.
Okay.
And refrigerant is only allowed if it can be proven that is the only way we can get these buildings turned around.
So when you say no gas, you mean no gas for gas-fired boilers?
That's right.
And no gas in terms of refrigerant gas, I think you mean?
Yeah, refrigerant
Yes.
and
Yes.
yes. Sir.
Yep.
But are you helped by F-gas, the legislation, which is about paring down the use of?
That helps, but when it comes to
Refrigerant.
turning around a building which needs to be turned around very quickly, we do have to weigh up the cost.
So these F-gas regulations are something started by the European Union and
Yes.
continued even after Brexit by the UK government, but it's about the phase down, the reducing the use of these refrigerant gases because of their effect on the
The
environment.
global warming.
Yeah.
So that is definitely helping us not use the cheap and cheerful equipment anymore.
Okay.
So obviously the newer refrigerants are more costly. So actually then...
But
when you
much
think of-
better on global warming.
Much better
potential.
on global warming. But then when you look at it compared to actually doing it properly, full heat pump, water-based system, then cost parity comes
Yeah.
into mind again.
Okay, so we've got. So you're not using the underfloor
So
system.
I think you said
because
that
you
this rarely works
encroaches
because
on
you
the
just
height.
haven't got much height.
Yeah,
Yeah.
so I mean, if the space was there, I think underfloor is still
Yeah.
the right solution because you want to, for
It's there
embodied
already,
carbon,
you might
embodied
as well.
carbon wise,
Yeah.
it works because pumping in air from a more cleaner section to kind of the heat rises, right? So if you put conditioning air in here, it's the right way to do it. You're gaining the heat up.
Are we doing more
yes,
heating or cooling these days?
Because of the structure of these buildings, normally you do find it's more heating.
Okay.
But as we do the fabric first approach, like Roger explained earlier, the buildings will start to get more sealed. So actually then cooling becomes more dominant.
Yeah.
And like the urban heat island effect and the actual climate change that we're seeing is meaning it's more cooling.
Okay, so there is a balance. It's
But
changing.
it's still a good thing to do. I
Yeah.
mean, it means that the heat demand goes down and the cooling goes up, but it's
Yeah.
still less overall. It's still a good thing to do. We're not making
Yeah.
the buildings overheat.
for-
yes,
yeah.
yes, it's
Yeah.
still a very good thing to do.
Well,
The
we all
more you
experienced,
can.
you know, that
Yes.
London this summer has actually been pretty unbearable.
Yeah.
How are your offices faring? I mean, you must have offices at all sorts of different kind of status of
A
development.
lot of windows were opened.
Yeah. But even that doesn't help when it's when it's so hot outside.
Well, this is why we need to think and have the right solution for these buildings going
Yeah.
forward, and pretty much all of them need to be updated. Like all the great estates who have these buildings have MEES requirements, so low energy standard requirements.
So this is to do with the efficiency of the fabric that gets used, isn't
Yeah.
it?
So by 2027, everything has to be EPC B.
So again, an
to be-
EPC is an energy standard which is used for judging buildings. Then the higher EPC rating, you get the better. And if you'll have one, we'll have one
Yeah.
for our houses now, don't we?
So that's a
And you've got
driver
one for your
that's-
fridge as well. You know those coloured bands.
Yeah.
So the higher the
You
better.
can't actually.
But what about the human driver behind? You
Well,
know, you must be seeing. You want people
we
to come
we
and,
want
and use
obviously
the
the best space for our customers, but a lot of developers might not have that drive. They might just need to rent the space out,
Yeah.
and that's where the MEES compliance comes in. So if you don't have that minimum EPC rating, you can't actually let the building anymore.
So this space that you have here, you're talking about energy performance certification, which is actually a driver that
Yes.
is becoming a legal obligation from landlords.
Exactly.
But what about the other drivers of comfort in the space, and how much do the Crown Estate actually think about the quality of the indoor space of the buildings you're providing?
It's one of the main drivers. Our customers have to have the best quality of space, and we have a duty to kind of provide that because we do have ownership of these beautiful buildings. We want the best clients, of the best customers in those spaces, and the best customers will come if you provide them a comfortable space.
And a good customer is one that pays the most rent, I suppose.
Pays the most rent and has the least complaints.
That's the least complaint.
So what was that?
But also
I'll
the
just
same
draw that-
ethos as you guys
Yeah.
in terms of the
And has the
green
sustainability
credit.
goals, yeah.
So what was that? What was that Venn diagram? We had three circles. What do we call them? So that this one of them was works better.
So this is for both the energy efficiency and the customers inside, the social values.
Yeah.
So like giving roof spaces for greenery, amenity, things like that.
This is looks better, which is just looks nicer, basically more appealing to people.
Yeah.
Sorry, that is too small.
Why does that matter?
So then you can
Well,
attract
we all want,
the
people buy things because they look good, don't
Yeah.
they?
Feel good.
Yes, exactly.
Looks
It
good,
looks
feels
high
good.
quality,
Yes.
considered.
Yes,
Yeah.
when I watch my family who are deciding which watch to buy, they do it on,
It's important, the package.
it's very important. Yes.
We're,
then
we're still very superficial creatures. So
Yes.
the first thing you see is what you can see with your eyes, right?
Yeah.
Before you start using your brain.
and the third diagram on the Venn diagram is
Outside.
yeah. And what we want to be is all in there.
Yeah.
And
Can I
that's
add one
really
more
what
to this? You actually have to have the technology
to
ready
make it work.
to
Yes,
make it
I mean,
work.
that's sort of implied in that, really, I suppose.
Yeah. So
Yes,
in there is
it's got to work. Yes, when
technology,
you turn
the
it on,
carbon,
yes.
and the
Yes.
social impact.
Yeah.
All goes in here.
Okay.
Yep.
But this,
What's it? Feasibility.
Feasibility from a technical perspective, you
Yes.
can actually do it. Viability from a commercial
Yep.
perspective,
Yep.
and desirability
Yep.
yeah,
from the
Yes.
people want to use
Yes.
it. Yeah.
that's it.
Yeah.
There you go. You
Lovely.
filled up the
Yes.
three
Yes.
circles
And
there.
that's
Yes.
the sweet spot.
That's the sweet
Yes.
spot.
Do you
and
feel that you guys managed to hit that? I mean, it's all a best balance of cost, carbon, comfort.
I mean, that is the goal. That is the goal, and we've just set off on a really ambitious development pipeline to achieve that.
Yeah.
The first buildings are going to come online in the next year, so we'll see if we've achieved it, but I think we have.
Fantastic. I love this. I mean, so Faraby, have you guys together answered your problem project?
I think it's a start, isn't it, Roger?
Yeah.
I mean, you just have to.
We know what we want to do.
Yeah.
You know, we want to make it all better, but there's challenges. It's got to be realistic and practical and stuff like that. And
I think it's getting everyone to think like this.
And that's got to stack up as well. That bit's got to stack up.
So do you find the biggest barrier to this is the way people think and the collaborative kind of big picture thinking, or?
I think it's the big picture thinking and the change-averse industry that we work in. The construction industry in general is very change-averse. Contractors come up with solutions which they've done for decades and don't really want to change.
Yeah.
So like everyone knows fan cool units.
Well,
Everyone
it's
knows.
nerve-wracking. It's risk.
Yeah.
Well, I mean, I have some sympathy for that because they've got to do it quickly with low margins. You know, they want as little as possible to go wrong.
Yeah.
You know, I can understand where they're coming from on that.
Yeah.
And what do you think is the opportunity that you can use to narrate the story of what actually can pull this through to happening?
Well, I think it's embracing the new technologies that's actually out there and seeing how they work and actually is beneficial for the contractors and the clients. Like there's technologies like even terminal unit technologies which are quicker to install and commission. That means the contractor's program can be reduced.
Yeah.
Which obviously they can pass back on to the developer or keep for themselves.
So you show by example can be better.
Exactly.
And once they've done it once, they've been
know.
more comfortable doing it again. And if we could just wrap up with one word that you think describes the future of our industry, what would it be?
I think it's endurance, because so we have these beautiful assets all around the country. They need to last for a lot longer, and they need to endure both the climate change and the kind of economic changes, and generate great quality space and generate great revenue for whoever owns them.
That's a great finish. Faraby, I do have one more question for you. It's a personal question that I like to end with. What is it that your family think you do? How would they describe what you do?
My 8-year-old son thinks I'm an eco-warrior.
Oh, that's a win. That's a win, Faraby.
A cape?
He has drawn me with a cape.
Oh,
brilliant.
And green stuff coming out my head, because obviously I have no hair.
Fantastic. That's brilliant.
He must be pretty proud.
Yeah,
Yes.
well, I try. I mean, we all have to chip in. I mean, this is the only planet we have, and if we don't do our part, it's not gonna be very habitable for the next generation. So I do it for my children, and if I have grandchildren, so they can have a space
Brilliant.
to enjoy.
Brilliant. It's people like you, Faraby, that are gonna give us hope.
Yeah.
And are doing it. So thank you, Faraby. Thank you, Roger, for joining. And thank you so much to our audience for tuning in. This is Retrofitting Our Reality. We invite you to come along and listen to the next podcast. And do follow us on Artus Air and also the Crown Estates and any of the other good products and solutions we've been talking about here. And we will see you next time.